We will go on to after this is how to measure pressure, because we have been using various properties such as pressure and volume and temperature and so on. We will look at a rigorous definition of temperature a little later on in the course, and at that point of time we will see how to measure temperature. Volume you can measure using, for example, a measuring cylinder, so that is relatively easy to do for things like liquids. And pressure is another parameter which we will keep talking about. So today what we are going to do is take a few minutes to see how pressure is defined. So pressure is defined as the normal force exerted by the fluid per unit area. We are mainly interested in fluids here, liquids and gases, so we are going to look at it in that context. So it's a normal force exerted by the fluid per unit area, and several people use different units. In this course we are going to stick to the SI units as far as possible. So the SI unit which we can use is, for example, Pascal, which is the force, which is the pressure if you have a force of 1 Newton being exerted by an area of 1 meter square. We will also use kilopascal quite commonly, and megapascal, which is, kilopascal is of course 1000 pascals, so megapascal is 1 million pascals. But what is often also commonly used is another unit which is called a bar, okay, or 1 barometer pressure. So bar is defined as 10 to the power 5 pascals, and the reason we use the bar is because it is very close to another unit which is the atmosphere. So if you look at a normal place on the surface of the earth, the pressure there is what we call as 1 atmosphere at sea level, and the relation between an atmosphere and a bar is that an atmosphere is 101.01325 bar, okay, or that is equal to 101.325 pascals. So in many calculations, especially when we want to quickly calculate out something and we would usually need the atmospheric pressure, we would often as a first cut just represent this as 1 atmosphere as say 1 bar, even where we do not take into account this stuff if we want to do a calculation quickly. But when you have a calculator and we would like to do it accurately, you should take into account all of this. So that is one reason we use the unit of bar quite commonly. The pressure can be either the absolute pressure or the gauge pressure. The gauge pressure is when we are measuring the pressure with respect to the atmosphere, and that is commonly measured using what is called as a manometer or a Bowden gauge. So for example, if you have a cylinder of this kind and the pressure inside is slightly above atmospheric, which is what is shown here, you could connect a U-tube manometer of this kind. So you have a tube which is bent in the shape of a U. We have some fluid here which hopefully will not evaporate and will not stick on the walls. So if the pressure inside is higher, then the liquid column over here goes down and comes up over here. We can measure the difference in the height of the liquid column, which is some h. We know the density of the manometric liquid, which is some rho. We have also the density of the substance inside and the substance outside. In general, we are dealing with gases. The density of the gas is much smaller than the density of the liquid, so that can be usually ignored. So if we do that, then what we can do is we can do a balance over here. So we have the pressure which is acting over here, the pressure of the gas, that must be equal to the pressure of the atmosphere which is here, atmospheric pressure, plus the pressure due to the difference in the height of the liquid, which is the density of the liquid times acceleration due to gravity times this height. So in this way we can find out the pressure of the gas, and since this pressure is with respect to the atmosphere, if you represent it as with respect to the atmosphere, we would get it as a gauge pressure. if you add the atmospheric pressure to it, and then you get the absolute pressure. So, if I wanted to just, if I do Pg minus P atmosphere, it will give me a gauge pressure of rho gh, and if I have this entire thing, then I would have the absolute pressure. Another device which is often used to measure the pressure is what is called a Bowden gauge, which looks something like this. What is important here is this blue colored tube. So, we have the system whose pressure we want to measure. We attach a gauge to this. We see this commonly on all gas cylinders and so on, but here it is shown as if it is transparent, so that you can see the mechanism inside. So, you have a tube. This tube has an oval cross section such that this cross section is actually perpendicular to the section of the paper. So, if you were to look at this over here into the plane of the paper, the dimension of this is larger and than this dimension here. So, it would be something like this, so that it is more likely to bend. So, you have this blue color tube over here. So, what is likely to happen is that if the pressure inside becomes higher, then there is high pressure gas inside, and this tube is likely to deform such that it deforms in some fashion like this. So, it is made in such a way it deforms along that about this axis. So, it goes out in this fashion if the pressure inside is higher, and the pressure inside is lower, this would come into a smaller circle of this kind. So, depending on the deformation of this, we have some levered arrangement such that it can move a geared mechanism, which in turn will move a needle, which tells us what the pressure is. So, we can have markings on it saying the pressure is like 1 bar, 2 bar and so on, and this needle would move and point to us what the pressure would be. So, this would be a Bowden gauge and this would be a manometer. These are two commonly used devices to find out the pressure. Now, in this again gives you usually the pressure with respect to the atmosphere. So, it would give you a gauge pressure, and you could add the absolute pressure, the atmospheric pressure to it to find out the absolute pressure, which is what we would do. But we also need to know what the atmospheric pressure is, and for that we use what is called as a barometer, which I think most of you are familiar with, but we will just quickly maybe just draw a schematic of it. So, you have a long tube, you can fill it with mercury and then invert it into a bath which also has mercury. So, if the tube was initially filled, all of this would have been having mercury. Once you invert it, because mercury is heavy, it goes down to a certain extent, and then so you have nothing over here, and then you have mercury in the remaining portion. So, we can once again write the force balance. So, you have atmospheric pressure which is acting over here. The pressure here is 0, and you have the height of the mercury column above this, which is here. So, if we write the balance for this, so the atmospheric pressure must be equal to 0 plus the height of this column. So, if I have the density of mercury into acceleration due to gravity, which gives me the mass, and I have the height, this must be equal to the atmospheric pressure. So, what we can also do is, since we know the density of mercury, which is about 13,600 kg per meter cube, we know the acceleration due to gravity, which is 9.81 meters per second square. We can, supposing the pressure was say 1 atmosphere, we can calculate what would be the height of this column. So, normally what we would do is find out the height of the column and then find out the pressure, but in this case, let us say the pressure was 1 atmosphere, we can find out what would be the height of the column. So, 1 atmosphere is 101,325 Pascal. This is 13,600 kg per meter cube, into 9.81 meter per second square into h. So, which can give us the value of the height. Okay. So, we can actually do this calculation, and I leave it to you to find out this value. Okay. But I am sure that you know this value already, because we have used it in several places, possibly in other places. So, it is usually given as about 760 millimeters of mercury, which is about 0.76 meters, but you should calculate it anyway and confirm that this turns out to be the case. So, what we see is that if you have a column of mercury which is about a meter, okay, 3/4 of a meter, that gives you a pressure of 1 atmosphere. It is also useful to get a feel of these numbers. So, for example, we said a bar is what we commonly use, which is close to an atmosphere. So, how heavy an object do I need to keep in order to get a pressure of 1 bar? Okay. Or for example, when I walk, how much pressure do I put on the surface? So, an easy way to look at this is a bar is about 10 power 5 pascals. Okay. So, if I had an object which has a mass of 1 kg. Okay. So, if I have a mass of 1 kg, the acceleration due to gravity is about 9.81 meters per second. I will approximate it to 10 for the time being. So, the weight of this mass of 1 kg would be m into g, which is 1 kg into 9.81, which is approximately equal to 10 newtons. Okay. If I keep an object which weighs 10 newtons, so it has a mass of 1 kg, if it occupies a surface area of 1 centimeter by 1 centimeter, okay. So, the area if the area it occupies is 1 centimeter square, then the pressure would be force by area, okay, that would be 10 divided by 1 centimeter in meters is 0.01 into 0.01, which would be about 10 power 5 pascals, which is 1 bar. So, what we see is that if you have an object which has a mass of 1 kg and occupies a space of 1 centimeter square, that gives you a pressure of about 1 bar. So, which is not all that much when you think about it. So, we are going to stop at this point. What we will do in the next lecture is to go on to work. So, just to recap, what we have looked at today is exact and inexact differentials. We see that exact differentials represent properties, they are state functions, you can locate them on maps. If you want to know the difference in anything between a state function, you can just subtract them out. So, for example, if I want to know the difference in height, so Chennai is at sea level. If I was to go to like say Bangalore, which is several hundreds of meters above sea level, if I want to know difference in height, I can just find out the height at which Bangalore is, find out height at which Chennai is, and subtract out the 2. That is sufficient for me. But if I want to know how I got there, the distance I travelled, then that depends on how I got there, and that is no longer a state function. So, we looked at those. Mathematically, we saw that they are represented in this fashion. What we would try to find out is this value and see whether they are equal, in which case it is exact, and if they are not, it is inexact. After that, we looked at pressure, we looked at values of units for pressure, and looked at how we can measure it. So, this is where we stop for the time being. Thank you.